Alright, welcome to Mr. Nelson's YouTube video. Today what we're going to be doing is you're going to be looking at one-step inequalities, how to solve them. We're going to look at the one time where you flip your sign and make sure that we understand every type of inequality and how to graph them. Okay? Alright, so let's get started. So, say I have the inequality of 5x is less than negative 25. Alright, so we need to know that right here on this side, on the left side, I have 5 and x. That does not mean addition, that does not mean subtraction, and it does not mean division. Okay, if you see a variable, which is x, next to a number like you see here, that means multiplication. Alright, so I have already set up my question. In your setup, you want to box your variable so you know what side you need to get rid of your numbers. So I've got x on the left side, so I know that I have to get x all by itself. So on this side, I will have x all by itself. Now, in order to get rid of multiplication, I have to do the opposite operation of multiplication. And the opposite operation is division. So I'm going to divide. Remember that that line means division. Okay? So I am going to divide by what number? Well, I'm trying to get x by itself, so I need to get rid of whatever number is on the same side. So 5 is on the same side as x. So I divide this side by 5. And if I divide it on one side, I also have to do it to the other side. The reason why I put this river here, or this street here, or this sidewalk here, is because that's where my inequality sign was. Okay? So wherever you put your street, you have to do it on one side of it and the other side. Now you need to remember your integer rule here. For multiplying and dividing, whenever we multiply and divide, we can use this. I've got a negative 25. I've got a positive 5. So I do a negative and a positive. Whatever's left is your answer. Your answer is going to be a negative. 25 divided by 5 is 5. I keep the sign the same. Now, even though this was a negative number, I'm going to keep the sign the same because I did not divide by a negative 5. If you would have divided by a negative 5, you would have switched your inequality sign because of the rule. Because if you multiply or divide by a negative number when you are solving for an inequality, you flip the sign. So let's look at one where we divide by a negative number. By the way, this is your answer. X is less than negative 5. So here's 0. Here's negative 5. It's an open circle because it's not or equal to. And less than is always going to be to the left. Okay? Alright, so say we have this x divided by negative 2 is 8. Okay? Alright, so in this one, we have, we're going to box our variable, we're going to draw our sidewalk so we can see both sides of our inequality. The reason we box our variable is to get x by itself. So in order for us to get x by itself, I need to get rid of, remember that line means division. To get rid of division, I have to do the opposite operation of division, which is multiplication. So I multiply this side by negative 2 because we're trying to get rid of the negative 2. So I multiply by negative 2. If I do it to one side, I also have to do it to the other. Okay. On this side, when I multiply, I make that into a fraction. And when I have negative 2 over negative 2, even though there's an x still on the top, those negative 2's cancel out. So all that's left is x. Okay, so all you have to know is that when you multiply on this side, those twos cancel out to where you just have x left. Okay, now, did I multiply by a negative number? I sure did. So when I multiply by a negative number, I need to switch my inequality sign, turn it around. Okay, again, we need to remember our integer rule of that nice little triangle. We've got a negative times a positive, and so our answer is going to be negative again. 2 times 18 is negative 16. So our answer ended up being that right there. Now, I highly recommend you moving your variable to the other side when you get your inequality that looks like this, because it's easier to read when it's on the other side. So I'm going to put my variable on that side. Now notice that it's eating the bigger number, which in this case is your x. Okay, so I'm going to move it to where it's eating the bigger number. Now I can read that a little bit nicer. It says x is bigger, because it's eating the bigger number, or equal to negative 16. Both of those inequalities say the same exact thing. Okay, and if you were to graph that, you'd have 0, you'd have negative 16, you'd have a closed circle at negative 16, and it'd be shaded to the bigger side, which bigger greater than is always to the right. Okay? All right, we did multiplying, we did dividing. Let's look at addition, subtraction. So say I have negative 5 plus x is less than 3. Okay? Now, I see that there's addition here. Okay? But what am I trying to get rid of? Well, I'm trying to get x by itself. I'm going to draw my sidewalk so I know which side is which. Okay? I need to get x by itself, so I know I need to get rid of this part right here. Okay? If I owe somebody $5, like what it says here, if I have negative 5, how do I get rid of owing them $5? That's right, I give them $5. And if I give them $5, that's a positive number. So, in order to get rid of negative 5, I have to add 5. If I do it to the one side, I have to do it to the other. Okay? So on this side, negative 5 plus 5 is 0, so they cancel out to be 0. So they're a big 0. Well, 0 plus x is just going to be x, so I leave my x. Inequality sign stays the same. 3 plus 5 is 8. No integers needed because those are both positive numbers. You don't have to worry about the sign. You just keep it the same that it was. All right. Now, if I've got x plus 5, let's see, let's go back. There we go. Is this. It looks similar, but it's a little bit different because our one step, instead of, bless me, sorry, instead of adding 5, we've got here, we need to get rid of adding 5. If I have 5 and I need to get rid of 5, that's right, I need to subtract 5. If I do it to one side, I have to do it to the other. Okay? These cancel to be 0. Any number plus 0 is just that number, so we put x, which is that unknown number. We keep our inequality the same. Notice, even though we are subtracting 5, we didn't flip our inequality because the rule is it's only when you multiply or divide by a negative that you flip your inequality sign. And that'll be a negative 2. How did I get negative 2? That's a positive 3 and a negative 5. Same sign, add and keep, different sign, subtract. That's a positive, that's a negative. That means they have different signs. So we're going to subtract. 5 minus 3 is 2. Keep the sign of the bigger number. Which one was bigger, 5 or 3? Well, 5 was bigger, so we look at the sign. That means it's a negative. So our inequality is x is less than or equal to negative 2. Again, here's negative 2, here's 0. It says x is less than or equal to, so it's going to be a filled in circle. Less than is always to the left. Okay? All right, so remember these. Oops. Remember these are an open circle. These are a closed circle. Try to keep your variable on the left side, and if you do move it from your left side to your right side, remember to switch the sign. So if I originally have 15 is greater than x, I'm going to move my variable to the left side, and I'm going to see here what it says for my x. Well, it says that x is on the small side of my inequality, so I keep it on the small side. Notice I had to flip it when I moved my variable. Okay? That is all you need to know about inequalities: how to solve them, how to graph them. Basically, if you see an inequality, solve it. Okay? If you can't solve it, it's already in its simplest form. You've solved for x in your inequality, then you can't do anything except for graph it or understand what a solution is for it. Okay? So what is less than 15? Well, 14 is less than 15. 13 is less than 15. There's a bunch of numbers that can be solutions for this. Okay? All right. That is one step inequalities.